Okay, yes, so we have to start with the revision of the wave optics. Ray optics we have completed in the last class. So let's just go through the major topics and the formula. And then I have a set of questions from your previous years. So that set of questions we'll be discussing. So what did we discuss? What all things are important in wave optics? Is the type and definition of a wavefront. That's your primary topic, and it's a basic fundamental part of the wave optics. So what is a wavefront? Continuous locus of particles that are vibrating in the same phase. And there are different types of wavefront. We saw the spherical wavefronts, the cylindrical, and the plane wavefronts. Then you have the diverging and converging too. And this is very important, the Huygens principle. Out of anything which you are practicing and performing, from your wave optics, Huygens principle has to be there. And the proof of Huygens principle in terms of reflection and refraction, both are important. So what does this say? This says that each point on a wavefront acts as a fresh source of new disturbance. And we say this new disturbance that has been produced. See, there's a source and it is producing a primary wavefront. Each point on these primary wavefronts, these are creating new wavefronts, which are called as the secondary wavefronts or the wavelets. And when you take the tangents on the envelopes that are formed, the forward envelope gives us the direction. So this is what is important for you to know, like this. This is the source. It is creating wavefronts. And see, these each point is acting as a source, and every source is producing a wave. So like this is how the propagation of waves are produced. So these are the different types we saw. Yeah, reflection on the basis of wave theory. So this is also important, this derivation where you have to prove this laws of reflection, and the second one is the refraction where you have to prove the Snell's law. Okay, this part is there. And then we saw the concept of interference also. In interference, what else we saw? The phase difference, we've seen how to calculate the phase difference, and then how to calculate the path difference from the phase difference. So this formula should be there at your tips, that phi naught by 2 pi is equal to x by lambda. This we had seen. A superposition is there. And then, yeah, Young's double slit experiment we have completed. And this is also one of the most important topics from your chapter of wave optics. You have a source. The sources are giving a small space, which we call as the slit. And through the slits, the source is escaping and creating bright and dark fringes. So these are the bright and dark fringes which you see. From here, what is important for you to know more than this derivation? See, this derivation is not much of importance, but you have the intensities equation, this final equation of intensity, and you should know that intensity is directly proportional to the square of the amplitude. So the resultant of intensity is written as I1 plus I2 plus 2 root I1 I2 cos phi, where again I'm saying this phi is the phase difference. Yeah, constructive interference and destructive interference should be there at your tips, because the concept of maxima, bright fringe, all are given through the constructive ones, and all the darker ones, the dark fringe, the minima, these are given through the destructive interference, right? So this formula for both of it, destructive and constructive, should be there, remembered by you. Then the maximum amplitude, maximum intensity. Okay, then this we saw. And what are the other things that we had seen? Interference due to white light. You should know just this theory part. This theory part can come as it is to right, where the light ray is split up into the different Vibgyor colors, right? The entire spectrum: violet, indigo, blue, green, yellow, orange, red. So this is there, which you should know. And intensity distribution curve is there. Directly see the curve, because this curve is applied in the diffraction also. So in the diffraction, what was diffraction? It was just the bending of light rays around the corners of the small obstacles or apertures that you get. So that geometrical shadow, that region of geometrical shadow which is produced is because of the process of diffraction. So again, here also in here, the derivation is also not of much importance, but you have the final conclusions which have to be remembered by you for both of it, for the maxima, minima, for both of it, whether it's diffraction, whether it's interference, the separation of the central maxima from the calculated one. This should be very clear to you. Like if this is the central maxima and you are calculating this fringe, this is the fringe, then this separation you need to remember. Okay. And rest of the things you will be able to manage from this. So see, the first question, this is, see, I've given you the options also. So calculate the time which light will take to travel normally through a glass plate of thickness 1 millimeters. Refractive index is given to you. You have to find out the time. So take this as the length. This thickness which is given, take it as the length. Okay, tell me which option is coming. Write it first, then I'll discuss this. Okay, see, for the calculation of time, see, we are going to use the concept of the refractive. And yes, yeah, any option?
I have one doubt. I'm near the answer. We take
Yeah, say.
1 mm as 10 to the power minus 3, right?
Yes, 10 to the power minus 3. Without that, see, you cannot take your answer in any unit and get it in seconds because we have to have a standard unit, right? And the standard SI unit, we know it's meters. So even if it's given in millimeters, you have to convert it. See, I'll tell you the solution for this one. The speed of the glass will be the speed of light by the refractive index, because we have studied that the refractive index is what? It's the ratio of the speed of the light in air by the speed of the light in the medium. So the medium is glass. It has clearly said that it's a glass plate. So the velocity of the glass will be now it will be the ratio of the speed of light to the refractive index. So when I put the speed of light, this is 3 into 10 to the power 8. And what's the refractive index given? Refractive index is given as 1.5, right? So this will also be 3 by 2. 2 gets cancelled. So it will be 2 into 10 to the power 8 meter per second. So that's the speed. We don't need the speed, we need the time. Now, the basic simple formula of your class 11th, your kinematics. What is speed? Speed is distance by time, right? Yes, right. Correct option. Yeah, very good. So time will be equal to the distance by speed. Distance is 10 to the power minus 3. And the speed we've calculated as 2 into 10 to the power 8. Right? So when this will be 0.5, it will be 5 into 10 to the power minus 12 seconds. Correct. So the right option will be option B. Please write the solution. We'll see some other questions. Now we'll see the questions based on the intensities. Okay, so this is a question from your sample paper, a very old one. So this says that two plane monochromatic waves propagating in the same direction have the amplitudes A and 2A. Now the phase difference is also mentioned to you. You have to simply find out the amplitude of the resultant wave. So we've seen a formula for it. Put it in the formula. See which option is matching. You will get your answer very quickly and it won't be incorrect. Try this first. Yes, class. Answers? Answer in the chat column, whatever answers you're getting out of all the options. Which one, Yaya? B or C?
C, ma'am. C, ma'am. I didn't see the option correct. C.
I think your previous answer was right.
B.
Let's see. See, first amplitude is given as A. A2 is given as 2A. And the phase difference is given as pi by 3. Okay, so resultant amplitudes equation is A1 square plus A2 square plus 2A1 A2 cos phi. So this will be A square, this will be 2A square, this will be 2A into A, and this becomes pi by 3. So this will be 5A square, right? 4A square plus A square, 5A square. And cos pi by 3, this is cos 60 degree, which is half. So 2 gets cancelled, right? Or see, this is 2A into A. So it becomes 2A square, right? This is 4A square plus 5A. This becomes
Ma'am,
2A. Yeah.
shouldn't it be 2A into 2A? Because A2 is 2A,
Okay,
right?
1A is 2, right? 1A is 2. So this will become 4A square. Then clearly B will be the answer. B option. See, this is 4A square into half. This becomes 2. That is root 7A square, which is equal to root 7A. So B option. How did you change then, Yaya? What was the mistake? Like you were getting it initially right and then wrong? What happened?
Ma'am, I forgot to place the 2A in that.
Acha, acha. Okay. Write it. Write down the solution, all of you. Then we'll see some more questions. Yeah, your practical exams are over. All the practical.
No, ma'am. I have one on Saturday and one on Monday, ma'am.
All right. These are the main board practicals or the revision practicals?
Main board, ma'am.
Okay. So how are they going? Physics is done.
Yes, ma'am. Physics was done. Physics was
How did
yesterday,
it
ma'am.
go?
Very nice, ma'am.
Okay. What was the experiment you got? Which experiment?
I got the Ohm's law experiment
Hmm?
and then the prism experiment.
Okay. Okay. Prism one is, I think, very nice. Students find it very convenient. Huh?
It was easy, ma'am. It was easy. Only the Ohm's law was only the
Hmm.
Ohm's law was difficult because I had
So
to make a
Viva,
circuit.
you were able to handle the Viva nicely?
Yes, ma'am.
Okay. Okay. Great. Great. Okay, this question has come after this. See, these data that I have written, these are the old one. These have repeated recently also in 2014 also this question came. So in a two-slit experiment with monochromatic light, fringes are obtained on a screen placed at some distance d from the slits. So this is the standardized symbol. We know that this is capital D. If the screen is moved 5 into 10 to the power minus 2 meters towards the slit, the change in the fringe width is 3 into 10 to the power minus 5. So if the distance between the slits is 10 to the power minus 3, the wavelength of the light that will be used will be out of all these, which one? So lambda you have to find out basically. Write the question first. C class, I hope you've written the question at least, all of you.
Ma'am, 1 minute. Ma'am.
Okay, write it.
Done.
See class, just understand what is this question saying, then you can try, because like this it would be very difficult for you to identify. I'll tell you the steps, go through the steps and then tell me. The answer is very easy to calculate from this because the values are fine here. The formula of beta, beta, that was the fringe width. So beta becomes lambda capital D by small d. This is the value. So there are two values of beta, right? One is the changed one is the one which is given. So just one thing, class, where students commit error is this sentence says the change in fringe width is given as this. Means this is not the new fringe width. Rather, it is saying the change in the fringe width is given as 3 into 10 to the power minus 5. Okay, when this says means there is a difference. See, there must be some initial value, which is this. There must be some final value. So the change in beta is given as 3 into 10 to the power minus 5 meters. So this is the change that is given. So just be careful when you're solving this. What is it? This is the change that has occurred. So beta is lambda capital D by small d. What is capital D small d? You can see from the question, everything is clearly mentioned. Everything you need not even write. Since here a change is given, what you do, you calculate the change also. Change in the distance of the slit means this difference. Is it given? Let's see. In a two-slit experiment with two monochromatic light, fringes are obtained on a screen placed at some distance d from the slit. Screen is moved this much towards the slit. So means this is the change in the distance that has occurred, right? This is also not the final value. If a screen was placed like this, okay, let's say this is some point. This is how the screen was placed. Now, if I bring this slit here, if I bring the screen here, closer. So I don't have the new distance. I just have the moved distance. This changed distance is given. So that's why this question becomes very important and a little confusing. So you have d minus d dash given. You have beta minus b dash given. Okay, so this is given as 5 into 10 to the power minus 2 meters. Now try the question and tell which option is coming right. Yes, class, if you're getting any answer out of all these, share the option in the chat box. Just take the differences. Differences will help you in this question. Because in this question, you don't have the direct final value. You have the change. The change is mentioned. Change in the fringe width, change in the screen separation. Yes, yeah, very good. You have written it in meters. Options are in angstrom. So you should just know how to convert it in angstrom too. Very good. See, class, beta is lambda capital D by small d. The new beta is some d dash. Lambda will remain the same and the separation between the slits will also be the same. Now, what is given? The difference is given. I told you the difference is there. Difference means beta minus beta dash is given. So that is d minus d dash lambda by small d. This is what is given to us. So what do we want? We want lambda. Everything else is provided to us except lambda. What will be lambda? Beta minus beta dash into small d divided by d minus d dash. Correct. So if we put it in all the values, see, do we have all the values with us? D minus D dash is, I have already told you that separations difference is given as 10 to the power 5 into 10 to the power minus 2 meters. Fringe widths separation means the change in the fringe width is there 3 into 10 to the power minus 5. And what is the value of the small d? 10 to the power minus 3. So small d will be 10 to the power minus 3 meters. So if we put in the values, this will be 3 into 10 to the power minus 5 into 10 to the power minus 3 divided by 5 into 10 to the power minus 2. So see, this is 30. Like if we take 1 0 from here, so that directly shows that this is something related to 6 and option C. So when you will solve, this will come out to be 6 into 10 to the power minus 7 meters, right? So when you are having this in meters, that is 6,000 into 10 to the power minus 10 meters, which is written as 6,000 angstrom. Okay, so this is what this question was all about. So it's a good question. All those who have not written, quickly write down. Written, others, Khadija, Siddiqa. Okay, this is the next question. Written the question?
Yes.
Okay, this says a beam of light consisting of two wavelengths, 800 nanometer and 600 nanometer. This is used to obtain the interference fringes in the Young's double slit experiment on a screen placed 1.4 meters away. If the two slits are separated by 0.28 millimeters, calculate the least distance from the central bright maximum where the bright fringes of the two wavelengths coincide. So we have done such question. Class 2 equations will be formed, but since it is saying no, the next one, where the bright fringe of the two wavelengths will be coinciding. Take one as n, take the other one as n plus 1. Okay. And use this to solve and say whichever option is matching. Then you will get it. Let's say this is for lambda 1 and take this for lambda 2. Now tell me which option is getting matched. You will get it easy. Okay, let me discuss now. So x is equal to n lambda 1 capital D by small d. Now this is equal to n plus 1 lambda 2 capital D by small d. See, small d, capital D will be cancelled. So n lambda 1 is equal to n plus 1 lambda 2. So n into 800 is equal to n plus 1 into 600. So 4n is equal to 3n plus 3. So n is equal to 3. Now, once you have the value of n, you just have to put it in place of the formula. So see, x will be equal to 3 lambda 1 capital D by small d. So this is 3 into, this is given as 1.4. This is 800 nanometer. So 800 into 10 to the power minus 9 divided by small d 0.28 into 10 to the power minus 3. So this will be 12 into 10 to the power minus 3 meters. So x is equal to 12 millimeters, right? Quickly write down those who have not written. Okay, see, this question says that light of wavelength 600 nanometer falls normally on a slit of width 1.2 micrometers. So, if you look here, we have to it is saying producing Fraunhofer's diffraction pattern on a screen. Calculate the angular position of the first and angular width of the central maxima. So, A sine theta is equal to lambda. So, from here, you can say sine theta is equal to lambda by, what is the wavelength given? 600 nanometer, 10 to the power 9. Or you have the width as 1.2, 10 to the power minus 6 micrometers. So this is equal to 1 by half, right? 12, 0 will go up, so this will become half. Now, when you have to calculate the width of the angular width of the central maxima, see, for angular width, if you remember, we did this is theta, this is theta. So total becomes 2 theta. So theta is equal to 30 degree. 2 theta becomes 60 degree. So this is actually the angular width. 2 times 60 degree. Write this. Then one last question we will see. Okay, written. So we have this last question left. So it says that a light wave enters from air to glass. How will the following be affected? So you have to tell about the energy of the wave and the frequency of the wave. Okay, look here. This says when it says that a light wave enters from air into glass, you have to see how the energy will be affected. So remember, energy always decreases. And when we are talking about the frequency, this remains unchanged. Okay, quickly copy this.